So today is March. So March is about a quarter of the way through the year, which is quite terrifying because it's going so quickly. March is also the month of International Pie Day, which excites me because I like pie. I also like leprechauns, and so happy St. Paddy's Day to everybody who celebrated that yesterday. I hope that you had fun and also social distanced. Yeah, so this is a picture of not social distancing at all. This is how we used to run this thing in the before times. The hope is that one day we'll go back to an in-person event and see all your lovely faces. But for now, we are still remote. We have a code of conduct. This code of conduct is quite straightforward and obvious, really. Basically, just be a good person. Just be kind to each other. If just keep in mind the fact that people are here to learn and grow. So yeah, respect that. If anybody gives you trouble, if anybody isn't performing according to our code of conduct, then please feel free to reach out to one of our wizards. So anyone on this page here is willing and able to help and will be receptive to your issues if you have any. We are real wizards, even though our hats are not so real. I'd also like to thank our sponsors. So we have two. Inosis sponsors the stream, so thank you. And the other one is Microsoft Azure. They sponsor our meetup. Microsoft has a cool newsletter, which you can sign up to if you follow this link. It's pretty interesting if you're into that, so check it out. If you would like to submit a talk, please do. We are very, very chilled with new speakers. So if you're new and you don't know if you can do a good talk, just chat to us about it. If you need help developing your idea, if you want to run through your talk ahead of time to make sure that it's cool, new and experienced talkers are welcome, and we'll help you out. And you can watch all our old talks right here on YouTube. So that's pretty easy. And that's it. I'm over to our first speaker, Duncan Dean. Welcome, Duncan.
Thanks so much. So, hey, everyone. This is my first time speaking at JoziJS, actually first time speaking anywhere. We're going to be talking about some Wasm stuff, and I thought the best way to get everyone's attention for talk title is to use alliteration. Yeah, so we went with that. A whimsical walkthrough of Wasm proposals. So just a bit more about me is that I'm a web tech lead at Luno. If you haven't heard of Luno, I can shill it at the end. Yeah, so a few more things. This is my debut talk, as I mentioned, outside of Luno. So other than a few lunch lectures and internal talks we do within the company, this is my very first talk. I have a background in physics, bachelor's in physics, and majored in maths. Usually my spare time is filled with playing around with Bitcoin and the Lightning Network, setting up nodes. If you want to talk to me about Bitcoin and scaling off-chain and transactions on the Lightning Network, then yeah, I'd really love to do that. And then also Wasm. But today we'll just talk about Wasm, and maybe I'll shill some Bitcoin in between. So also a disclaimer and a few things about this talk. We're staying in the shallow end of the pool, going slightly deeper. There's lots of in-progress and standardized features for Wasm already, but I'm only going to talk about 4. And these 4 I'm kind of partial to because they're my favorites. Yeah, and I think I'm the most excited about them, but there's a whole bunch of other proposals out there. I'll mention them at the end, and then you can just dive into them in your own time. So first of all, for anyone unacquainted, WebAssembly, also referred to as Wasm, and I'll use these two interchangeably throughout the talk, So just verbatim from webassembly.org is the definition: WebAssembly is a binary instruction format for stack-based virtual machine. We'll see a little bit more about this as we go through the talk of what a binary instruction format is and the stack-based nature of Wasm. And just for interest's sake, is that in 2019, WebAssembly became a W3C recommendation officially. So it became the 4th language of the web alongside HTML, CSS, and JavaScript. And why it might be interesting to you is that although WebAssembly has its own human readable format that you can write in, usually you want to use it as a compilation target. So it supports, well, a wide variety of languages already supported as a compilation target, from C++, Rust, and assembly script, which supports it. I'd say the most have the best support for it so far. Then you've got Go and your Swift Wasm projects, many languages with LLV backends already supports it natively. So yeah, so if you write in a language, it probably has a WebAssembly. It can be converted to WebAssembly via some backend. Yeah, so you don't need to write it by hand. So as I mentioned before, it has a human readable format called WAT, WebAssembly text format. These things have interesting names, as you'll see later on, because we love to name things that are a bit silly and funny, and yeah. So this is an example of WAT. So it's just a function that we've defined, takes in a single parameter, and outputs a result. They're both I32 type. We'll see the 4 types that you can have as parameters and results in WebAssembly a bit later on. So local.get to get that first name parameter, then we'll add it to the stack. Local.get again to add the same parameter to the stack. And then I32.add is an instruction that takes the top two items of the stack and then adds them together and then places the sum on the stack. And then that's returned from the function. So that's sort of the human readable format. And if you use a tool from Wabbit, it's W-A-B-T, there's a tool called WAT2Wasm, or WAT2Wasm, and it takes your WAT code and it compiles it into a Wasm binary module. And so this is just a hexadecimal representation of it. We're not going to go into the encoding at all, but it is very interesting. So I definitely recommend going through that in the spec. There's a lot of videos you can follow that actually make it a lot of fun, and reading hex Wasm modules by hand or by eye. Okay, so just to throw some practical examples out there of it being used in the wild. So if you don't know, Figma is a design interface editor for the web. It's written in C++ originally, and it was compiled to asm.js, which is basically a very restricted subset of JavaScript that can be compiled that can be optimized quite easily by browser engines. So obviously they wanted to bring their tooling that was written in C++ to the web. So before WebAssembly, you had things like asm.js via mscripton. And then they decided, with the whole WebAssembly reaching minimum viable product in around 2017, they decided, okay, they're going to be at the forefront of web technologies. And shortly after its MVP, they managed to compile their code base to WebAssembly. They noticed 3x speedups for the design interface file loads. And I'm sure it's just gotten better from there. Another example that is not in the web, but might be interesting, is that Flight Simulator 2020 actually uses Wasm modules for third-party aircraft simulations. So they decided to not go with dynamically linked libraries. And they chose Wasm modules importantly for portability and sandboxing. And often you'll see that wherever there's discussion about sandboxing, even outside the web, WebAssembly is a top candidate these days. So in Flight Simulator, Wasm is converted to native code ahead of time. And the nice thing about Microsoft going all in on WebAssembly for Flight Simulator was that in the process, they created some pretty awesome C++ and Wasm tooling for Visual Studio. So we've come to our first proposal, which is JS Begin to Wasm I64 integration. So if I gave you a simple sum, and let's just say it's a JavaScript number, I've put in separators so it's easier to see the triplets of zeros. So this is 100 quadrillion. And if you know a thing about JavaScript numbers is that if you try this out, you're going to get 100 quadrillion again. And that's a bit weird. But actually, it's expected because JavaScript number has limitations. The spec is basically double precision floating point numbers that it uses. And it can represent integers with that spec in binary representation. So there is a very specific limitation, is that max safe integer. So the maximum integer that you can safely represent in that binary format is that integer on screen. So it's funny enough that the odd integers after this integer you cannot represent at all, and then things start to break down further down the line. You can read the spec about floating point arithmetic and representing binary numbers, but we're not going to go too much into that because meh. But now we have big int, of course, and it's very widely supported. We'll just ignore Internet Explorer because insert Internet Explorer joke here. I'm not going to make my own. They don't come free. So what if? So the way of specifying a big int literal is to use the n suffix at the end. So you can have 100 quadrillion n plus 1 n. And from that, in big int, we'll get our expected 100 quadrillion and 1. Okay, everything works out then. So this is an example of a Wasm function where you'd use it. And I said I wouldn't be shelling Bitcoin, but I thought it would, it wouldn't be my talk if I didn't. So, so this is a Wasm module. We've defined a function, and its export's name is checknet millisats. So sats are satoshis. It's the smallest unit of a Bitcoin. But on the Lightning Network, you can actually go smaller than that because it's off-chain. So you can get millisatoshis. So when you start working with millisatoshis, you can actually get to numbers that are larger than a max safe integer. So this is why we'd need to work with I64 and big int. So your parameters, so I'll just explain. This is just a really simple function just for demonstration purposes. So you'd have 3 input parameters, and we'd say your first 2 parameters would be the inputs to a Bitcoin transaction, the input amounts, and your third parameter would be your output amount in a Bitcoin transaction. And then the results would be the remaining amounts, because Bitcoin transactions, the inputs amounts added up must be greater than or equal to the output amounts. The difference is minor fees. So if you have no difference in the inputs and outputs, then your transaction's probably not going to go through because you've got no fees. So what we do here is we'd add the first 2 parameters to the stack. So this takes the 0th and first parameter and then puts it on the stack. We'd call the i64.add instruction. And then that would push the result of the add onto the stack. And now we'd get local.get2, which is our third parameter, and that would get pushed onto the stack. This is our output amount for the transaction, and then we'd subtract that from our two inputs, and you'd get your fees basically. And yeah, there would be no issues with being higher than max safe integer. So our second proposal that we're going to look at is multi-value. Specifically, it's around multiple return values, or for a function or WebAssembly blocks. So at the time of MVP, Wasm functions could consume multiple values, so they still can consume multiple values as operands, but they could only return a single value. And I mentioned before, I'll explain, the only 4 types that you can consume as values and return as values are the integer and float type, so I32, I64, and then the corresponding F32, F64 types. So they can be returned as a result. So let's say pre-multi-value, you'd have to do some trickery. You'd have to set some global variables. So we just initialize them at 0. We're just using I32s here. We're not worried about big numbers or overflows or anything like that. And then you define a function opswap. So this is something you see in a lot of stack interpreters. It will swap the 2 values on the top of your stack. So if we take in 2 parameters, I32, both I32 types, and we'll add them to the stack, local.get 1 and local.get 0. So we're adding the second one to the stack, and then the first one will be on top of that, because each item we push it onto the stack. So it's the last item that you push that's at the top. And then we'll do global.set 0 and global.set 1. And then outside of the function, you'll figure out which globals to access. And it's extra code. It's a little bit messy. It increases your bundle size, your Wasm module size, and it's a little bit slower because of the global variables. But with multi-value, this actually becomes a lot smaller. It's opswap. Then you still have 2 input parameters, but this time you can have 2 results, 2 result values. So you can have, so then you do the same thing. You add the second parameter to the stack, and then the first parameter to the stack, and then it will just return, just like that. So you've basically swapped it. You don't need to do anything further. Those values on the stack will return. So that's pretty cool. That makes it a lot smaller and more efficient. So the third proposal we're going to look at is actually really cool, because it has to do with using WebAssembly modules as ES modules. So it hides a lot of the instantiation stuff under the hood. So currently there are 2 ways to get Wasm into JS land. And it either involves using WebAssembly.instantiate streaming, and then you'll use a streaming source like fetch. And then where I've cut out that object, you'd have that would be your import object. So if you create memory, then you'd add it to that object, and then your WebAssembly module can use that as an import. Or you can actually add functions there that can be imported. So you'd await this, so you could do it within an async function or with top-level awaits. And then you'd access your result object.instance.exports.exported function. So exported function would have been defined in the WebAssembly module, and then that's how you would call it. The other way is compile streaming. This is if you want to first compile your Wasm module in case you want to pass it around or do some other things before instantiating it. Before having the cost of instantiating it with memory and other things like that. So you can see that at the instantiate step, that's where you'd actually give your import objects. You wouldn't do it in compile streaming because that's not part of instantiation. And then the same way to access your exported function. There are non-streaming equivalents to instantiate streaming, compile streaming, but they're not really recommended because they're less efficient. For example, instantiate streaming does not if you look at just instantiate, that uses an array buffer as an overload in the middle, and instantiate streaming doesn't, so it hasn't got this extra overhead. But now, wouldn't it be nice to just get that exported function straight, as if you're importing it straight from your Wasm file? Well, this is what the ES module integration proposal wants to accomplish, amongst other things. So you just import it like any other exported function from an ES module, and then you can use it straight away. So another thing that this proposal would enable is Wasm modules to be able to take part in JS module dependency graphs. So if you had a JS module counter.js, so this is not really doing anything specific, it's just returning a defined variable, and you exported get counts, you could actually import directly in a similar way within your Wasm module without creating a whole instantiate streaming and import object. So this is a lot smaller and a lot more succinct, and I think it's also more maintainable. The one thing to notice is that in the Wasm below, in the WAT file, you must specify a signature for your function. So you've got the func get counts, func results i32. So that just gives, it tells it that the results value should be an i32 because it can't determine that just from the input. So the fourth proposal we're going to look at is really quite interesting. It's still in phase 2. It's threads and atomics. So just a bit of background is that each Wasm module, it's nicely sandboxed, and you can give it access to its own linear memory as an array buffer. But this proposal actually adds a new shared linear memory via shared array buffer under the hood. So if we look at how to create a new Wasm memory within JavaScript, so this is even for non-shared memory, you'd use WebAssembly.memory constructor, and you'd give it an object with initial and maximum page values. So WebAssembly memory is measured in pages, which are 64 kilobits each, or kilobytes each. And this proposal adds a shared property that you can set to true, telling it to use a shared array buffer under the hood. And then what you can do is each WebAssembly module that you instantiate, you can supply it with that very same memory handler so that they can all access that same shared array buffer. And how you'd import it from Wasm land is that you'd use an import statement from that environment property, then you get your memory out of there. And then it's also like a signature that you give memory 1, it's the same initial maximum, and then shared, declaring it as shared. And why would you want to do this? Well, or how would you actually accomplish using threads in WebAssembly is that you'd need to instantiate a WebAssembly module in different web workers or in your host, in your main thread, and then share that memory with a web worker. So I call it Wasmizing your web workers. And that's instantiating WebAssembly modules within different web workers. And the way you would get the memory over to the shared memory over to the web worker is you just use post message. Obviously, this just sends the wrapped object. It doesn't send the whole shared array buffer over. And then your WebAssembly can access that shared array buffer directly and work with that linear memory via atomic operations. So you'd have your normal i32.add and or your get and your stores for your data, and then there are also atomic variants of that make sure that no worker is stepping on another worker's toes when it comes to memory. Some use cases, like why would this actually be useful? Well, it's great for any parallelizable task. So things like gradient, noise, and other image filters. Interestingly, TensorFlow.js, I think since 2.23, version 2.23 or something, they did some tests with MobileNet v2. So they had SIMD, which is also another WASM proposal, and threads enabled for WebAssembly across web workers versus WebGL, and it actually outperformed WebGL for inference on MobileNet v2. Yeah, so there's a Google, I can maybe share it afterwards, but there's a Google blog post about that. So also a bit of warning around using this. Okay, first of all, not mentioned here is that it doesn't, like, it might not fit your use case to use it. There is an upfront cost to instantiating modules and web workers. So you just got to make sure on the clients you're targeting and your actual application if it makes sense for you. But if you do want to use WebAssembly threads, browsers now require cross-origin to be cross-origin isolated. So you'll need your co-op and co-op headers. You can see more about this at web.dev/co-op-co-op. So Chrome actually currently allows shared array buffers by default. So the use of shared array buffer by default. But from Chrome 91, you must opt in with to be cross-origin isolated like above. That's just to make sure that everyone's going according to the same spec. And then they had site isolation before, but so that, you know, that's fixed some of the problems with Spectre and Meltdown. But I think everyone decided on one spec and yeah, went with that. So you can actually check if you are opted in correctly with self or window.cross-origin isolated. And it should return true. And that means if your browser does support threads, you can go ahead and use it and shared array buffer. So I'd see the current state of proposals, actually. So we didn't go through all of these, but you can see that there's been a lot of standardized features. Chrome and Firefox seem to support most of them. Some might be behind feature flags. Safari still a little bit behind with the standardized features. In progress proposals, so that's still like, you know, here be dragons. Things might change, but there are some interesting things coming up. And as you can see, there's also Wasm time and Wasmo. So those are out of browser land, so they're their own WebAssembly runtimes, not in the browser. So it's for other applications, even server side. So yeah, I mentioned about 4 proposals out of this whole list that is currently listed on the WebAssembly spec repo. So some have been standardized. There's a lot of other interesting ones you should maybe dive into. The ones that are lower phases, those are like stages in the ECMAScript spec. The API is subject to change pretty quickly, so don't commit to using it in production if it's even supported, because it's probably not supported at this stage. But yeah, can go ahead with the standardized proposals. Those are ready for production use. Great, but why should we actually care after seeing all these proposals? Well, the important thing to note is that WASM, it's a compiled target. You're not necessarily, unless it's for fun, you're not necessarily going to write a bunch of WAT and, you know, compile directly from that. You're going to use other languages that you can bring to the web, like Rust and C++ and Go and assembly script and, you know, all sorts of things. And what these proposals allow is they either give us new powerful features and deeper integration like the ES module integration, so that WASM becomes easier to work with. And then also, like we saw in multi-value, is that the proposals can make our outputs, our WASM output, smaller and more efficient. So this is better for users at the end of the day, because they need to download the WASM modules and then also instantiate them, and then you can reduce the runtime costs of functions, and it's just all around good news. Yeah, so that's me actually. Thanks for listening, and yeah, I'll go ahead for any questions if you have. I think you mute.
Oops, thank you. Yeah, so there aren't any questions yet, but we have recently changed how we receive questions. So it might just be because of that new weirdness. I figure let's go on to the next talk. But everyone who's watching, you can ask questions for Mike or Duncan just in the YouTube chat as we go along, and we can just tackle them all right at the end. So next up is Mike Geyser. Never mind. There is a question. Mike wants to know if you currently use Wasm in production.
So within our own company, unfortunately not, but there are actually some plans to use it for our new sort of, how can I describe it, presentational state machine, so that we can also deploy it to mobile apps as well as our websites. Yeah, but I wouldn't say we're not using anything currently. There was also some talk in the works about using WebAssembly for an anti-glare detection. So instead of sending it server side, that you can do that on device for web as well, and then also reusing that code on mobile devices. So you only need to write once and then deploy everywhere.
Okay, that's cool. You use WebAssembly in production?
Oh, yes. So no, we don't use WebAssembly in production yet.
Okay. Okay, cool. That is the plan. Right.
Cool.
Any other questions? No? Looks like it's Mike's turn.
Hey, hello. Hi. Suddenly I'll stop asking questions. As you may have guessed, we're new to this StreamYard streaming service, so we're trying to figure out who clicks which buttons. So I apologize for accidentally clicking buttons a little bit earlier. Duncan's talk was amazing. I learned so much about WebAssembly from it, and I have even more questions, but I'll leave them for the moment. So I'm here to talk to you about what I think you should know about core web vitals. Now I'm going to start off with this talk with a big open-ended question. Now I enjoy open-ended questions, like the important ones, like why? Why should we care? Why are we here? Why is it so cold? But in this particular one, we're going to be asking, why do we care about the core web vitals? Now, as those of us who work in the web know, or in any software know, that performance is seldom prioritized as a feature until it's way too late, right? Until everything's on fire and we have problems. And the web vitals are a part of changing that culture, specifically in the web. Now, as to why you should care particularly about performance and performance on the web, maybe you or your users, or you feel that your users have a desire not to be bombarded by moving parts that are ancillary to the experience, that sort of interrupt your users and get them away from the content that you're trying to show them, or the path that you're trying to take them down. Or maybe, maybe you care about the impact of ads and unexpected shifts where, you've been there where there's suddenly a big stinking ad that loads on something and you click a button, you're like, wait, no, I didn't mean that, I clicked on the ad instead, and it's awful. Or maybe it's one of those websites where it looks like it should be doing something, and then you click and you're not sure, and you click, 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 and then suddenly, firstly, the emotion turns to rage, and then secondly, you open a million tabs, or you buy a million things, or something completely unexpected. Or maybe, like us, you are on a continent that has lots of problems with connectivity and has a proliferation of lower to medium end devices that we use. And in those cases, we should care about performance on the web so that we can build experiences that we can consume ourselves. Or maybe you're just a business and you care about the rands and cents of the situation. And there are compelling reasons as to why you should care about performance from those perspectives. Maybe you care about having competitive advantage over your competitors. Maybe you care about growing your business organically via Google search. Or maybe, like I said, you care about exploring new markets with an existing product and going into completely different spaces. Now, the one thing that I will mention, particularly in context of Core Web Vitals, as to why you should care, is because there is actually a big deadline looming. For anybody that knows anything about search, you would know that Google intends on using the Core Web Vitals that we're going to talk about in their search engine search ranking algorithm as a part of something called page experience. And on top of this, it's not an ephemeral. They've been super, super clear that they only really care about mobile experiences. So if you take nothing away from this talk other than the time has come for you to only build exclusively for mobile first and desktop second, hopefully that's a key takeaway for you. Now moving on to another open-ended question, which is what are these things that you're talking about, Mike? You've told me I should care about them. Now, there are 3 core web vitals that are currently in the stable. Now, those are firstly, largest contentful paint, which is essentially how long it takes for the largest image or piece of text or heading to appear on the page, and is used as a user-facing metric for how long the page is perceived to load initially. And they trialed a whole bunch of different, more complicated metrics, but this one, finding the single HTML element on the page that loads, that's biggest, and how long that takes to load, is a very simple thing to calculate. So that gives us very robust, stable metrics to measure in production. Then something else called first input delay is effectively how long it takes for the user to be able, or for the page to be able to respond to user input, as a sort of understanding of interactivity and how quickly the page is interactive, or like lag in other terms. Measuring this can be complicated, but first input delay is a simplification on other lab metrics that we'll talk about a little bit later. And then finally, the third metric that we really care about is cumulative layout shift, which is the visual stability of the page. So during page load or during the usual viewing of the page, how stable are things? Do they shift around? Does stuff jump when you scroll? Does the page jitter as it loads with images? And it's a very, very interesting metric, and it guards against some very cynical patterns. See the click-jacking example of earlier. But it's also a very difficult metric to optimize for because it's counter a lot of our UI pattern or UX patterns that we enjoy on the web. And at the moment, there are only these 3 metrics, and these are the only ones we care about for May. But we expect that the set of metrics will grow over time as things are meaningful. So first, contentful paint. So the first time any content is painted to the screen may be introduced on top of largest contentful paint. We know that because it's such an interesting and innovative metric, layout shift will be weighted more than it is currently in other tools, which we'll talk about again a little bit later. And an outstanding problem is trying to figure out what does that layout shift mean when you get to sites that are more than just a content page that loads that you interact by scrolling up and down, when it's a single page application that you're going to interact with for a long period of time, or it represents an infinite scroll. Beyond that, for first input delay, we're trying to figure out whether the current metrics make sense, or how long is enough to measure a good performing site in terms of that lag for input. I mentioned single page applications, but basically single page applications are not just hurt by cumulative layout shift, but by all of the metrics. Scrolling and smooth scrolling of pages, and then the vitals themselves are going to be used very heavily, possibly even past the page experience report for mobile. And we're not sure exactly what that'll look like, but we're getting a developing understanding, and I expect to see a whole bunch more in coming months. Now an important one, because if you've been to any of my talks before, you know that I really enjoy Lighthouse. But now there's this other thing that is these core web vitals, and what is the relationship between them? How do you measure apples with apples across the two? So to explain this, we need to talk about run. And no, I don't mean that kind of run. I mean real user metrics. So measuring actual data from actual people in the field. So to understand the important difference between Lighthouse and the core web vitals, you need to understand the difference between lab data versus field data. So importantly, if you take a look at any data, so let's say this is first input delay, for example's sake, your data is not a single point, it's not a single number, it's a histogram that represents a range of different possible first input delays or loading times or whatever the case may be, some of which is good in the front of the graph and some of which is bad near the back of the graph. Now that is your field data. Typically, what we do is we use percentiles to figure out. So like the 50th percentile would be not the average. It means that 50% of your users have this experience or better. 95th percentile would mean that 95% of your users have this experience or better. And 75th percentile, which is the one that we commonly use when talking about this stuff, means that 75% of your users will have this experience or better. Now, the reason why 75th gets chosen rather than 95th is because with any kind of statistical stuff, the tails on either end can distort the bulk of the data. So by taking 75th, you get a little bit of stability in terms of measuring that number, so that number doesn't fluctuate unnecessarily. When we're talking about Lighthouse, Lighthouse is a lab tool, which means that you run it in a controlled environment, either on your machine, and I know some people's machines are uncontrolled, but you understand what I mean, or on a server somewhere, or on a set of devices that are running in a lockdown environment, simulating users actually accessing your page. And the data that you get out of a Lighthouse run, or several Lighthouse runs even, ends up being a single number. It is the average of those runs, or even if you do whatever you end up doing in terms of statistically figuring out what you think your metric looks like in the lab, Lighthouse is going to sort of approximate the 75th percentile result, okay? So Lighthouse tries to reflect the worst end of your statistics. Won't be accurate, it won't ever match up, but the idea is that your 75th percentile core web vitals should be close to your Lighthouse results. Now, that should is really important because in theory and practice are the same. In practice, they are not. So if we take a look at Lighthouse, and this is where Lighthouse comes in, it lets you iterate really, really rapidly. You can do it on your local machine. You can run a couple things. It gives you really, really good actionable feedback on stuff that you can do right now, but it doesn't necessarily represent what's actually happening in the wild. So if we take a look at the individual metrics that represent Lighthouse, firstly, when we look at cumulative layout shift, Lighthouse only measures the layout shift on page load above the fold. So the second the user scrolls down, any shifts that happen underneath that are on top of it. So if you take a look at CLS in the wild, it's going to be higher than your Lighthouse score, almost guaranteed. First contentful paint should be very similar because your first contentful paint could be above the fold, but keeping in mind that if people are deep linking to a big long document and they're going to a specific item on that document, your first contentful paint might actually be halfway down the page, right? If you've got a hyperlink that goes straight into an anchor tag there. And then for first input delay have two proxy metrics that get used in conjunction in Lighthouse data. And those are total blocking time and time to interactive. Now, total blocking time is the amount of time that JavaScript blocks execution or queuing of tasks on the main thread. And time to interactive is how long it takes for there to be a 5-second gap of silence in your CPU data or your CPU usage. Now, those should match, and those are similar, so they should be close results, but in practice, that could vary quite dramatically. So it's just something to keep in mind, that the lab data and the field data don't necessarily align completely because you're measuring two different things and you're building an association between them. But if you take a look at it, between CLS, FCP, TBT, and TTI, those metrics make up the bulk of the Lighthouse score. So if you can improve all of those in Lighthouse, you should be able to guarantee good results in Core Web Vitals. But importantly, there's an adage: test in the lab, iterate in the lab, but validate in the field. Don't just trust your lab data and assume that it's going to be right and everything's going to be okay. Check to see what your users are actually affected by. So let's pivot a little bit and let's talk about what tooling is available to help you in this endeavor, right? So we're going to start off with Chrome DevTools. Now, this is very specifically the performance panel in Chrome DevTools. And I'm just going to focus on a couple small elements that are relatively new or are relatively good to look at for the stuff. I don't pretend to understand all of this. One day when I'm big, I will. To start, we can see that they surface things like the LCP, FCP, and layout shift events as a part of the timing section. So there is a little tag that you can click on that says LCP, and it's going to show you, well, this is when your largest contentful paint happened. And at the bottom there, it's going to tell you exactly which item it picked up as your largest contentful paint, which is super useful. On top of that, under experience, it's going to show you every time the layout shifts. There's going to be that reddishy orangey block that says, cool, here is something shifting on the page. And you can see what those individual events are. For FID, or first input delay, you can see all of the tasks that are queued, and the fact that they're queued end to end and that there are no gaps in between them. That means from this point onwards, it's very difficult for a user event to wait for JavaScript to finish running before it itself executes and can be acted upon. Moving on from DevTools itself, we've got a slightly higher view, which is CrUX data. Now, CrUX is the Chrome UX report, and it's basically everybody that's opted into anonymous usage statistics for the web to say, well, cool, I'm going to give people information, Google information about what my load time is so that we can make the web faster. Now, currently, the CrUX data set has the top 8 million origins available in it, and you can query it directly in BigQuery if you're one of those people. You can use the CrUX Dashboard, or you can use the CrUX REST API, which is exposed. And on the right-hand side, you've got an example of a very simple sort of high-level chart that's been created using the REST API. Now, I've recently really started playing with the dashboard, and it's actually pretty fantastic. you can go in and you can get it to export data to Google Data Studio with a pre-built report that tells you what your segmentation of the core web vitals are. And for example, on screen, you can see the largest contentful paint, how many users have a good experience versus an experience that needs improvement versus a poor experience. And you can figure out, based off your usage statistics, how big that problem demographic is, as well as what the 75th percentile of that data looks like, which is really, really useful. And it looks like it's free. I don't understand. It's amazing. Back to Chrome in the browser, there is work being done. Obviously, the core web vitals can be surfaced straight from Chrome. You can, in your dev tools, you can in Canary, but soon you will in Chrome proper, be able to show a small HUD that shows what the core web vitals are for any given page. And if you're impatient like me, you can just go and download this extension that does literally the exact same thing. And it gives you the web vitals for every single page that you want. It's backed by essentially the same code. There's no real difference. The one's just going to be built into Chrome, so you don't need a separate extension for it, which is cool. So how? I've shown you the tools. I've shown you the what. Explained to you the what? Whatever. How do we go about optimizing these things? Well, let's tackle them one at a time. And we're going to do this at a very high level because, unfortunately, the devil is in the details. But if we take a look at LCP and how one optimizes for it, basically, we want to optimize how quickly the user sees the primary page content, which means that anything that's blocking the critical render path, we need to get out of the way. Now, there's two large camps as to how to do that. The one is to get the JavaScript out of the way. So get any JavaScript and CSS that you don't really need to be deferred until DOM content loaded. So all of the DOM content is there. Everything is physically on the page, and then run the scripts that augment or modify the page. So that's one school. The other one is to just speed up the content download itself to prioritize that. So you can pre-connect and pre-download critical content so that as soon as we hit that in the HTML, it's immediately visible. And that improves LCP in that score. And if you can, I can strongly urge that you consider pre-rendering or at least server-side rendering as much content as possible. Because if you can deliver all of the HTML without needing to create it using a JavaScript library, it will be immediately visible. That's what the browser's designed to do. And if you're digging through stuff and trying to figure out what to do, I would caution you to be careful with isomorphic or universal JavaScript, because it muddies the water as to what's a server-side concern versus what's a client-side concern, and becomes difficult to optimize. Moving on to CLS, layout shift is really, really hard, and every single UX pattern that we use that might be intentional or unintentional, cynical or not, has a different case around it. But the one thing that I can definitely say is that you'll benefit from inlining critical styles. So the things that handle where stuff is on the page, so that the content blocks, be that images or be that pieces of text, don't move around on page load. A simple one is to explicitly set height and width for images so that the images don't push other content and they immediately reserve the space that they need. Fonts are another example. So you can use font display optional to, when you're downloading a font, not wait for it and block rendering, but give it a finite amount of time to download and then just ignore it and use a base system font. And then importantly, defer CSS if you can. If you don't need it on page load, don't load it on page load. And don't send down styles that you don't need for that page view. And then finally, optimizing for FID, or first input delay. I often find that anything that touches JavaScript is the fulcrum for front-end performance. That's the part where we're making everything a lot more difficult for ourselves because of the frameworks and libraries and approaches that we've chosen. So for this, basically what you want to do is you want to minimize how long you spend blocking and executing code on the main thread. So you want to do as little as possible and do them as late as possible, or do them on demand. So the first thing that's difficult to say is to reduce long-running tasks. If you've got lots of code, see if maybe any of that code you can cut up and do on a request idle callback, or defer it for later on, or do it on a click event or a user interaction event, just so that it happens later on. Or for first input delay specifically, try and queue micro tasks so there's gaps between all of the contiguous code, so that if the user does interact, there's an opportunity for it to respond quickly. And then the last one, just be careful with the code that you bundle and ship, and don't send code down to the user that they're never going to execute and they don't need. And like, I really don't know how to be clear enough about this, that you shouldn't be sending code to an unbounded set of users that they're not going to use. Don't ship it. And I think on that point, I'm near done. So if anybody has any questions about Core Web Vitals specifically, performance in general, I would be really, really happy to field them.
Thanks, Mike. That was super cool. I am not seeing any questions rolling through. Yeah. So I think that is that.
Okay, cool. Well, if anyone does have any questions, I'd be, just feel free to reach out to me on Twitter or on the meetup group itself.
There is one question, but it hasn't actually arrived yet, so I can't click on it. I don't know how to do this.
Are you looking into the future, Jerry?
Does that mean that we're back to flavoring multi-page apps in some respect?
I think obviously it depends. It depends on the use case and it depends on what you're building. But I think that simplistically the answer is yes, because if you're building a whole bunch of pages that the user may or may not visit, and you're sending them all down to that user before they've had the choice of where they want to visit, in the case of a single page application, I think that's always going to perform poorer. And even in the design patterns that we're using in modern web, we're now trying to build our web pages, or we should be trying to build our web pages the way that we used to build client-side experiences like desktop applications, and the way that we build mobile applications, which is to separate the concept of the sort of container and frame that the application runs in and the stuff that it executes, like individual pages, and only load those pages as and when they're needed. And we've got the ability to, on click event, first download the code, then execute the code, and then show the user a new screen. I think that makes a lot of sense. So even if you're building a JavaScript heavy application that doesn't have multiple server-side renders, I think it's clear that we should be treating our apps as separate pages. But having said that, like, HTML has survived this long for a reason. It's really good at what it does. We should just be sending people HTML. All of our problems go away.
How do I So Ivan asks, how do I optimize for Web Vitals in the legacy system?
Yeah, so that's an interesting question. And the answer is obviously going to be it depends. It depends on which frameworks you're using, and it depends on the constraints that you've got. I think that there's a justifiable use case for doing it. And often what you'll find is that older applications don't have the same problem. So if you're talking about legacy as like 10 years or older, or anything running jQuery, it's actually probably going to be far better than the things running React of 4 years ago, right? Those are a bigger issue. So in terms of optimizing legacy apps, I think that there are a couple there are a couple things that you can do. So the first thing is that historically we would ship ES5 and ES5 only that was uglified or minified. And we don't have to ship all of that code anymore. We've now got native imports. We've got Terser language constructs. We don't need polyfills. We've got good support for modern language features. We should be using those, firstly, and that's just a case of tweaking your bundler. And then the second thing is just apply a simple thing where defer all of the scripts, not some of them. Don't try and figure out what your load order is. Just defer everything. Because the beauty of deferring script using script type module and defer is that it guarantees execution order. It'll load all in parallel, but then when it gets to DOM content loaded, it'll run them in the order that you put them in the page, which is the same as if it was blocking. So that's a really easy way to improve FID on a legacy application. Yeah, and for the rest of it, it's just pre-connecting as appropriate.
All right.
Okay, I think we're done.
Yeah.
We survived.
We are. Yeah, go team.
Awesome.
Thank you
very much,
everybody who attended.